Hello everyone and welcome to my video on factors affecting nucleophilic substitution reaction, lecture 5, where we are going to discuss about the effect of concentration of reactant on the rate of nucleophilic aliphatic substitution reaction, that is SN1 and SN2 reaction. Now substitution reaction depends on 5 factors: the nature of the substrate, the nature of the solvent, strength of nucleophile, nature of leaving group, and concentration of reactant. Factors 1, 2, 3 and 4 are discussed in my earlier videos, and link of these videos are given in the description box for your reference. Today we are going to focus on the 5th factor, concentration of reactant. Generally, the rate of chemical reaction depends on 3 factors. A. Total number of effective collision per cubic centimeter per second, that is called collision frequency. B. Fraction of collision that has sufficient energy, that is called energy factor. C. Fraction of collision that has proper orientation. This is because the reaction occurs due to collision between the molecules of sufficient energy and orientation, and that only leads to the product. And so the rate of the reaction is equal to collision frequency into energy factor into probability factor. But how is the rate related to the concentration? The change in concentration of reactant can only affect the collision frequency, neither but not the energy factor nor the probability factor. Now, under this condition, the rate of reaction is equal to collision frequency. More the concentration, more is the number of molecules crowded in the given space. This may result to more often collision between them, resulting in the increase in collision frequency. And we know that more the collision frequency, faster is the rate of reaction. The field of chemistry which deals with the dependence of the rate of reaction on concentration is called kinetics. So let's look at the kinetics of nucleophilic aliphatic substitution reaction with reference to SN1 and SN2 reaction. Methyl bromide reacts with hydroxide ion in aqueous ethanol to give methanol plus bromide ion. This is an SN2 reaction. Now, if the reaction results from the collision of hydroxide ion with methyl bromide, then the rate of reaction will be dependent on the concentration of both the reactant. If the concentration of hydroxide ion and methyl bromide is double, the collision frequency should be double and the rate of reaction also should be double. Again, if the concentration of the hydroxide ion and the concentration of methyl bromide is half, the collision frequency is supposed to be half and the reaction rate also should be half. Experimentally also, same thing is observed. Therefore, the rate of reaction is proportional to the concentration of methyl bromide into concentration of the hydroxide ion. Again, rate is equal to K into concentration of methyl bromide into concentration of hydroxide ion, where K is equal to the rate constant. Now, this reaction is said to follow a second order kinetic since the rate is dependent on the concentration of 2 substances. But look at this reaction. Tertiary butyl bromide reacts with hydroxide ion to give tertiary butanol plus bromide ion. This is SN1 reaction. Now, here it is observed that when the concentration of tertiary butyl bromide is double, the collision frequency is double, and so the rate of reaction is also double. When the concentration of tertiary butyl bromide is halved, the collision frequency is also halved and the rate of reaction is also halved. But when the concentration of the hydroxide ion is doubled or halved, there is no change in the collision frequency, and so there is no change in the reaction rate. Therefore, the rate of the reaction is equal to K into concentration of tertiary butyl bromide, where K is equal to the rate constant. This reaction is said to follow first order kinetics, since the rate is dependent on the concentration of one substance. Now, what does the K value indicates? Let's see for the second order reaction. In second order reaction, rate is equal to K into concentration of methyl bromide into concentration of hydroxide ion. At a given temperature and solvent, K is constant and is a characteristic of a particular reaction. The unit of K for second order reaction is liter mole inverse second inverse. If the concentration are expressed in moles per liter, then the K value indicates, K value is a number which when multiplied with the concentration gives how many moles of methanol is produced in each liter during each second. So what does the K value indicates? K is just a number which when multiplied with the concentration of methyl bromide and the concentration of OH minus gives how many moles of methanol is produced in each liter during each second. Coming to first order reaction, the rate of the reaction is dependent only on the concentration of the alkyl bromide. Here also, at a given temperature and solvent, K is constant and is a characteristic of a particular reaction. The unit of K for first order reaction is second inverse. For example, for a reaction of tertiary butyl bromide in 80% alcohol at 55 degrees centigrade, that is, the solvent and the temperature is constant, and so the rate constant is also constant for the reaction. So the rate constant is 0.01 second inverse. But what does it mean? This means for every mole of tertiary butyl bromide present, 0.01 mole will react each second, whatever be the concentration of OH minus ion. Now let's see the correlation between rate constant, reaction mechanism and energy profile diagram for SN1 and SN2 reaction. Are they in the same lines? Let's see. This is the mechanism for SN2 reaction. It goes through a single step and the reaction proceeds, gets converted from the starting material to the product through the formation of an intermediate. Now, in this step, if you want to get the product methanol, then methyl bromide molecule has to collide with OH minus in this step to give methanol. Therefore, the rate of the reaction is dependent on both the concentration of methyl bromide and OH minus ion. And the energy profile diagram of SN2 reaction also shows that it is a single step process where the reactants are converted to the product through the formation of a transition state. Now let us look at mechanism of SN1 reaction. It is a two-step process, and the first step is the slowest step, leading to the formation of intermediate where nowhere the base is involved. Therefore, the rate equation is dependent only on the concentration of alkyl bromide and not on the concentration of the base. Why is the first step the rate determining step? This is very clear from the energy profile diagram. E activation for the first step is more than the second step, and so the first step is slow, and we know that the slowest step is the rate determining step. So step 1 is the rate determining step for the SN1 reaction, where base is not at all involved, and therefore in the rate equation we do not involve the concentration of the OH minus ion. The concentration of the OH minus ion is not present in the rate equation. So all these things, rate equation, reaction mechanism, energy profile diagram, leads to same conclusion. That's all for today's video. If you like my video, please subscribe, like, share and comment. Thank you and bye-bye.